Welcome to the video for the homework assignment for solving equations or systems of equations, all three methods. This is example 3. So this video we will just be doing example 3. There'll be other videos for the other two examples. So if I'm looking at example 3, I notice that both equation 1 and equation 2 are in standard form. And the x's, the y's, and the numbers are all lined up, which means to me the fastest method to do this, or the best method, first would be elimination. So I am going to rewrite the problem down here. And then I'm going to decide which variable would it be easier to get rid of. I look at the x's and I ask myself, can I multiply 2 by anything to get 3? No. Can I multiply this 2 by anything to get 4? Yes. So if I'm interested in multiplying only one equation, I would suggest multiplying this bottom one by a negative 2. Why not positive 2, you ask? Well, if I multiplied by positive 2, this would still be a negative 4, and it would not cancel out. But if I multiplied negative times negative, this would become a positive 4, which would cross out. So the first equation I did not change, so I'm going to recopy it. The second equation, if I distribute the negative 2 in, I would get negative 6x plus 4y equals negative 4. And now I want to combine down. So if I do that, the 4y's do cross out, and combining down I get negative 4x equals a positive 8. When I divide by negative 4, I get my x value to be negative 2. Now my goal, though, is for a system to find x and y. So I'm going to take the equation that I did not change, and I'm going to plug in negative 2 for x. Negative 4 minus 4y equals 12. I'm going to continue to solve this equation. So I'd have negative 4y equals 16. So if I divide by negative 4, I would get y is negative 4. So I think that my answer, based on the elimination, should be the point negative 2, negative 4. Now, I can check my work. I could take these 2 points, x and y, and plug it into the equations to see if it makes sense. Or I could do another method or two to see if my answer makes sense. And so, just like in class, I am going to do graphing next. So I'm going to come up here, and I am going to change both of these equations to slope-intercept form. 2x minus 4y equals 12. So I am going to solve for y. And yes, I recognize that some of you might be looking at this saying, can I use x and y intercepts or the cover-up? Yes, of course you can. I'm just doing this for practice. Y equals negative 2 over negative 4 reduces to 1/2, and this becomes a positive. So my slope is positive 1/2 x minus 3. So this line is the first I'm going to graph. So I'm going to come over here, start at negative 3. Go up 1 over 2, up 1 over 2, and I'm going to keep doing that a few more times until I get a nice line. Might as well go this way, down 1 over 2, down 1 over 2. So there's my first equation. The second one, if I take 3x minus 2y equals 2, and I solve for y equals mx plus b, because that's usually the fastest way to graph if intercepts are not an option. If I divide by negative 2 here, just be careful with your signs, you would get y equals, again, another positive slope, negative over negative. Positive divided by a negative gets me a negative 1. So if I graph this second line, that is not where I start, excuse me, let me erase that. How dare I? So in the second line, I would start at the y-intercept of negative 1, and then I would go up 1, 2, 3 over 2, up 1, 2, 3 over 2. You can also go down 1, 2, 3, left 2. And if I do that, it seems like my lines are going to intersect right here, and I need to make sure that matches my previous answer. This is where it looks like my graph is intersecting. That looks at like it. Negative 2, negative 4, which conveniently is the same answer I already got. This makes me super duper happy. Now the toughy McTuff in this problem, the substitution. If I would like to solve this one by substitution, you have choices. You could take one of these equations and one of these equations and set up a substitution problem. So you could do, like, if you wanted to keep 3x minus 2y equals 2 and leave it like that, and then you wanted to take this equation here and use a system, you're more than welcome to do so. But again, in class, I'm going to be consistent with what I did the other day. I noticed that the work I just did, that I have y equals 1/2 x plus 3, and I also have y equals 3/2 x minus 1. So if y equals this and y equals that, that means that 1/2 x minus 3 must be the same as 3/2 x minus 1. Which, another way to write that would be 0.5 x minus 3 equals 1.5 x minus 1. So what if I solve this equation? What if I subtract the 0.5 x to the other side? I would get negative 3 equals 1.5 minus 0.5 is 1x minus 1. And then I add the 1 to the other side. This is looking promising because I again get x equals negative 2. Awesome. If I want to continue this and find y, I'm going to use one of these two equations. I will just use y equals 1/2 x minus 3. Now I'm going to take negative 2 and I am going to plug it in for x. If I do that, 1/2 of 2 is 1, but it's negative. So it's negative 1 minus 3, which again is negative 4. Awesome, awesome, awesome. 3 times, I got the answer of negative 2, negative 4. Feel free to pause and go back and re-listen to any piece of this. Your answer should have been negative 2, negative 4 each time, no matter which way you solved it. Feel free to ask questions at this point as well if you have any. If you need another problem, I did videos for the next two, numbers 4 and 5. Okay? Thank you for listening to this one. See you at the next video.